Good afternoon, ladies and gentlemen. Just here to help you out with your homework tonight over absolute value inequalities. I want to talk to you using a couple of really basic examples. This first one is the problem the absolute value of x is less than 5. And this one's really simple in that you can probably think about it in your head what makes sense. Obviously, any positive number that is less than 5. So if I'm just ignoring the absolute value, any positive number that's less than 5, any number that's to the left of 5 in the positives is going to work for this. 1, 2, 3, 4, all of those are less than 5. And if I take their absolute value, they're still less than 5. It doesn't really matter that the absolute value is there. However, when you think about it, there's some negatives that are also going to work for this. If I am at 5, you know 5 is going to be my boundary because it says the absolute value of x is less than 5. I have one of two choices. I'm either to the right or I'm to the left. Let's just test a number on each side to see what works. Let's start over here with negative 6. If I take the absolute value of negative 6, I get 6. And that is supposed to be less than 5. Is 6 less than 5? Of course not. So I know that that number does not work. But let's try the other side. Let's try negative 4. Take the absolute value of negative 4, I get 4, positive 4. And that is less than 5, which should tell you, oh, this arrow to the right is correct. And in other words, anything that's actually greater than negative 5, not less than, works, as well as anything that is less than 5, as we already said. Now you might be like, how does this apply to those problems in which we have lots of things going on and you've got to solve? Well, the truth is, this practical thing right here can be applied to any absolute value inequality. Let me just explain the shortcut. The shortcut, drop the inequality sign, or drop the absolute value sign. Switch the other side. Switch the other side. So whatever that inequality sign is going to become its opposite. And whatever sign this is over here, in this case it's positive 5, will become a negative. And notice that does work. I do get exactly what I got the long way, which was testing either side of negative 5 to see what would actually work after I took the absolute value. And this will work for all inequalities, even ones that are complicated. So let me give you an example of one that is a little more complicated in hopes that this makes a little more sense. Let's say that I had the absolute value of x plus 4 greater than 6. Well, in this case, my absolute value is already by itself. So again, thinking about positive numbers that are going to make this work, I can go ahead and ignore the absolute value sign. I can go ahead and solve the inequality x plus 4 is greater than 6. If I do that correctly, I'm minus 4 from each side. I do get x is greater than 2. And that's totally true. Think about it. When you add things to 4, what numbers are going to be greater than 6? Well, anything 2 or above, right? Because 2 gets you to 6. So anything higher than 2 will get you higher than 6. So this totally makes sense. And this is, again, an open circle at 2 going to the right. But again, there are negative numbers that are going to work as well. And if you think really hard about this, I need this side to be negative 6, right? I need this to be bigger than negative 6 in some way so that when I take the absolute value, I get a number. And if you think about it in your head, this is actually going to be, I believe, negative 10. Because when you add negative 10 to 4, you get negative 6. So it's going to be any number lesser than negative 10, anything that like negative 11, negative 12. But you might not be like me. You might not be able to do that in your head. So again, the trick, just like last time, I'm going to keep what's in the absolute value preserved, keep it the same. I'm going to switch my inequality sign. So now instead of greater than, I'm going to be less than. And instead of positive 6, I'm now going to be negative 6. Now that I'm here, I'm going to go ahead and solve it the same way that I did before, minus 4 from each side, and I will get x is less than negative 10. And again, you can test this if you think about it. Pick a number that's less than negative 10, like negative 11. See if it works. Negative 11 plus 4 is actually negative 7. The absolute value of negative 7 is 7. And yes, 7 is greater than 6. So I know that I'm right. If that's still confusing you, I would love to help you in class tomorrow and explain it a little more, perhaps clearly, so that you can understand. But again, if you want it as a 1, 2, 3, step 1 would be to just drop the absolute value sign and solve it as is, and that's the work I did over here. Step 2 is kind of a two-parter, so I'll list it as 2 steps. Step 2 is to also, again, drop the absolute value sign, like I did over here, no more absolute value sign. But then you need to switch and flip your signs. So you switch this sign to its inverse, and then you flip the inequality sign as well to its inverse. So really the whole right side of this problem, everything that's not in the absolute value gets changed. There's a reason why I'm doing that. There's an algebraic reason. But if you just memorize that, oh, this is greater than 6, I need to change it to less than negative 6, you will be just fine on this homework. We'll talk about it more in class tomorrow. Thanks, guys. Have a wonderful night. Good luck on the homework. Make sure you only do 11 problems. Please read the directions on that. Thanks.